Hi everyone, how's it going? In this video, I'm going to go through how to use the software SkyCiv, and particularly the beam calculator and the free version of the beam calculator that you can use to draw shear force and bending moment diagrams. All right, so let's have a look at it. All right, so here it is. So you can find it, the URL's up here, but if you just Google SkyCiv, SKYCIV, and free beam, it'll come up pretty quick. So this is what the free version looks like. There's a premium version, and for students at UTS, I've got a discount code that you can use, so I'll show you that. But anyway, let's just use the free version. It's pretty easy. So just start, and you can see you just got to work through these steps. Let's start by adding a beam. I'm just going to go through some of the example problems from the textbook. So here below, mechanics and materials, and I'm just going to model those. So I'm going to start simply with a simply supported beam with a uniformly distributed load. So I'm just going to add a beam, and I need to put in the length. So the length is 4. Add that, and I need to add a support. So we've got a pin support, and it's at the left, so I can just click in there left, or I could type in 0. And so I need to add another support. So I want to put in a roller support, and I want to put it at the right hand end, or I could type in 4. Add that. Now I don't need a point load for this problem. I don't have an applied moment couple. I have a distributed load. So let's put that in. So it starts at 0, ends at 4, and its magnitude is 3 kilonewtons per meter. And this is a uniform along the length, so it starts at 3 and finishes at 3. So this shows you that we can put in a varying load. So just a uniformly or linearly varying load. But anyway, let's just do the uniform load to start with. And that's it. We've modeled our beam, and we can now click solve. Goes away, does its calculations. This is a little bit slow. It's normally a bit quicker than that. And we come down and we get our shear force diagram and our bending moment diagram. And if we go and have a look at our textbook, we can see that, yep, we get 6 as the maximum, and the maximum occurs at 2. And the shear force diagram is the same. Now, what you don't get with this free version are the hand calculations. Okay, so probably can't see them there, but if you get that, then that'll do the calculations, or show you the hand calculations and the equations that generate these curves. So here we had V is equal to 6 minus 3x, and our moment was 6x minus 1.5x squared. So, and you need to draw your method of sections and show your internal actions. So this free version is just a good check for this. All right, let's go on to the next one. Do another example. So example 6.2. Let's go back here, back to beam setup. Let's reset it. And so we want to add a beam. We want to make it 3 meters long. Add that one. And we want a support. This time we want a fixed support at the left-hand end. Add that. Now we want a distributed load that goes the whole length here. And it starts at 0 and finishes at 2 kilonewtons per meter. Add that. So we've now modeled our beam. Let's solve it. Go down here and we get our shear force diagram and our bending moment diagram. That's our bending moment, so minus 6. So yes, that looks good. And our shear force diagram, 3 to 0 and 3. All right, so that's that one. Let's go to the next one in our textbook. Next one is, I think we might skip that. It's pretty obvious. You can start from 10 and finish from 30 instead of starting from 0 like we did with that problem we just did there. Let's go to something a bit more interesting. So a few more things happening. I'm just going to drag that over there so we can see them both at the same time. Go back here Back to beam setup, reset. Yes, reset it. All right, so add a beam, and this time it's 10 meters long. Add that. And we want to add a support at the left, which in this case is a roller support. Add that. Add another support at the right, pin support. Add that. Now we want a point load. Acting downwards, load position is 5. Load magnitude is 15. Add that. Add a moment. So we want a clockwise moment. Moment position at the left-hand end. And we want it to be 80 kilonewton meters. Add that. Yep, it's good. Now we want a distributor load. Starting position is 5. Ends at 10. Starting magnitude is also 5. End magnitude is also 5. Add that. All right, so we've now modeled our beam. Solve that. And we get something like this. All right, so hopefully once you've done a lot of problems by hand using the textbook approach, then you should be able to anticipate what your free body, what your shear force and bending moment diagrams will look like. All right, so don't rely just on this. You should still know how to do the calculations by hand. You should be understanding where all this comes from. But this obviously is, while you're learning, is a good way to check your solutions. And then once you're confident that you know where these come from, and just by looking at them you can tell whether they're correct or not, then you can just make use of this without having to do the hand calculations. But of course, while you're learning, it's really a learning tool, not a shortcut tool. Okay, so our our shear force diagram matches what we get by doing the calculations by hand and drawing our free body diagrams. Scroll down here, and our bending moment diagram matches also. Okay, so that's it for all of those examples. Let me see if I can quickly find a hinge in it. In fact, let me put a hinge in this one. Let's go back to beam setup. Let's add a hinge and see what happens, right? So we're going to do more than that. We need to have a hinge and another support, because if we just put a hinge in here, it's going to collapse. Right? So let's just play around and see what happens. Oh, right, I can't do it with the free version. All right, I'm going to pause the video and log into my premium version, I think, and come back and show you this. Right, I'm now in the student version of the premium version of SkyCiv. So it's an upgrade from the free version, but it's not the full suite. It's still a student level, but you can see now we've got access to a lot more functionality and a lot more apps, and many more apps. So we've still got the SkyCiv beam that we've been looking at. We've also got a 3D frame software, section builder for working out cross sections for your beams. We've got a truss frame analysis app, and so on. All right, so let's go into SkyCiv beam again, do another analysis, and we'll rerun that problem that we just did, but this time. Okay, so here we are. Let's create the beam again. So it looks a little bit different now because we've got a few more advanced options. So the beam is 10 meters long. Add that. Yeah, so this is not quite as neat as the previous version, but does the same thing. So we want a roller support at the left, so pin support at the right. Add that. Yep. Now we need to go back, and we want to do a point load. Position 5. Oh, we can do mid. 5. And then we want to go back, and we want a moment clockwise at the left, and we want it to be 80 Newton meters. Add that. Good. Back, and we want now a distributed load. Start from the left. No, we don't want to start at the left. We want 5 meters and end at the right. Starting magnitude was 5, end is 5, and that. Good. Right, so we've now modeled that beam. Let's solve that. Okay, so let's scroll down here. So again, we've got our bending moment diagram. Let's compare it with what we had over here. So, yep. And now, let's look at our shear equation. My load here was 5 instead of 15, so fix that up. I need to make that 15. Save that. Right, now let's solve. Okay, so now we have our proper reactions that match what we did by hand. Scroll down, and our bending moment diagram looks right. We've got the same values. Shear force diagram is the same. But what you'll see now is that we've now got the equations to match our equations over here. All right, so we had for the bending moment minus 2.5 x squared, etc. So we have the same thing in our SkyCiv simulation. And if you click on here, you can see the full hand calculations. Describes what we're doing. Right, so you can see we've taken the cut somewhere between the changes in load, M1, some of the moments about the cut end. There we have our equation. So what was it? 5.75 plus 80x. Right, matches what we had over here. And you can download those as a PDF also. All right, let's go back to the model and put in a hinge. So let's add a hinge, and let's put it halfway along the uniformly distributed load here. So let's, well, not halfway along, let's make it 8. Like that. So we've got a hinge there now. Let's just see what happens if we solve that. It's probably going to tell me you can't do that. Okay, yep. Tells me that it's unstable, which I already suspected. Right, so we need to put in another support. So let's do that. Let's put in another roller support. And where will I put that? Over here somewhere. So let's put it 2 meters. All right. Let's see what it does with that. All right, so really, if this really was 2 rollers here, one could lift off the other one. So let's just see what it does. All right, it's worked it out. All right, so you can see things change on our bending moment diagram. We've got 4 equations to deal with now because we've got 4 changes in loading. Step change in the shear force diagram. Right, because now, where's our free body diagram? All right, now we have a force here. Right, so where we have an external force acting on the body, then we have a step change in the shear force diagram. And then you can have a look at hand calculations for the reaction forces. Okay, so I can't do everything for hinged problems. I'm not going to go into that in detail. You can play around with that as much as you're interested, just to see what happens, just like I did. So hopefully that was interesting. Yeah, at least have a go with the free version. And for UTS students, we get a 3-month access to this upgraded version for $10. All right, hopefully that was helpful. See you next time. Bye.